Hi everyone, welcome to my channel. Today in this video, we'll see about the evolution of reusable launch vehicles. Let's start the video. The Falcon 9, developed by SpaceX, is a two-stage, partially reusable rocket designed to transport payloads into various orbits and beyond. Introduced in 2010, Falcon 9 has become a cornerstone of SpaceX's launch services. Known for its reliability, cost-effectiveness, and reusability, the rocket's name is derived from its 9 first-stage engines. And it has undergone several iterations, with the latest being the Falcon 9 Block 5. Optimized for rapid reuse and increased performance. The Falcon 9 rocket stands approximately 70 meters tall and has a diameter of 3.7 meters. Its first stage is powered by 9 Merlin engines, which uses RP1, a refined form of kerosene, and liquid oxygen (LOX) as propellants. These engines are arranged in an octaweb configuration, providing redundancy and enhancing the rocket's reliability. The second stage is powered by a single vacuum optimized Merlin engine, which is also fueled by RP1 and LOX. This stage is responsible for delivering payloads for their final orbits. One of Falcon 9's most notable features is its reusability. SpaceX has developed and refined techniques for landing and reusing the first stage of the rocket, significantly reducing launch costs. The first stage can return to Earth and land either on a drone ship, at the sea, or on a landing pad near the launch site, showcasing SpaceX's engineering prowess and paving the way for more sustainable and economical space travel. The Block 5 variant of the Falcon 9 introduced several improvements aimed at increasing the number of reuses of the first stage, enhancing performance and simplifying refurbishment processes. These enhancements include more robust thermal protection system, increased thrust, and more resilient landing legs, among other upgrades. Block 5 is designed to be reused up to 10 times with minimal refurbishment, making it a key component of SpaceX's vision for routine spaceflight. Falcon 9 has been used for a wide range of missions, from launching commercial satellites to delivering cargo to the ISS and deploying SpaceX's Starlink satellite constellation. Falcon 9 has been used to launch Crew Dragon spacecraft as part of NASA's commercial crew program, transporting astronauts to and from the ISS. The Falcon Heavy, developed by SpaceX, is a powerful partially reusable heavy-lift launch vehicle designed to transport substantial payloads to a variety of orbits, including geostationary transfer orbit, low Earth orbit, and interplanetary missions. Introduced in 2018, Falcon Heavy has quickly become one of the most capable rockets in the world, known for its impressive payload capacity and reusability features. The Falcon Heavy rocket stands approximately 70 meters tall and has a diameter of 3.66 meters. Comprises 3 Falcon 9 first stage cores strapped together, effectively providing 27 Merlin engines for liftoff, compared to the 9 engines of the Falcon 9. These engines use RP1, a refined form of kerosene, and liquid oxygen as propellants. The central core is reinforced to handle the additional loads and stress from the 2 side boosters. The second stage of Falcon Heavy is the same as that of Falcon 9. powered by a single vacuum optimized Merlin engine using RP1 and LOX. One of the defining features of Falcon Heavy is its reusability. The two side boosters, which are essentially modified Falcon 9 first stages, are designed to return to Earth and land either on drone ships or on landing pads near the launch site. The central core is also designed for recovery, although its landing is more challenging due to the higher speeds and stress experienced during flight. Successful recovery of these three stages significantly reduces the cost of access to space. Falcon Heavy has incorporated several advancements in its design, leveraging the lessons learned from the Falcon 9 program. This includes enhancements in the thermal protection system, landing legs design, and improvements in engine performance and reliability. The Block 5 variant of the Falcon Heavy, like the Falcon 9 Block 5, features upgrades and facilitates rapid reusability and increased performance. The rocket successfully launched from Kennedy Space Center's historic Launch Complex 39A, carrying a unique payload, Elon Musk's personal Tesla Roadster, with a mannequin named Starman in the driver's seat. The side booster performed a synchronized landing back at Cape Canaveral, while the central core attempted to land on a drone ship but narrowly missed. The mission demonstrated Falcon Heavy's potential and captured global attention. Starship, developed by SpaceX, is a fully reusable spacecraft and rocket system designed for a wide array of missions, including crewed and uncrewed flights to Mars, lunar missions, satellite deployment, and point-to-point travel on Earth. The system comprises two stages, the Super Heavy booster and the Starship spacecraft. Both stages are intended to be fully reusable, significantly reducing the cost of space access. Starship's design features a stainless steel construction providing strength, durability, and ability to withstand high temperatures. When fully stacked with Super Heavy booster, the vehicle stands around 120 meters tall. The Starship spacecraft is approximately 50 meters tall and 9 meters in diameter, offering substantial payload capacity and internal volume. One of the most significant aspects of Starship is its Raptor engines, which are full-flow stage combustion engines using liquid methane, CH4, and liquid oxygen LOX propellants. This choice of propellant supports the vision of Mars colonization, as methane can potentially be produced on Mars. The Raptor engines are designed for high performance with a sea-level thrust of about 2 meganewtons and specific impulse of approximately 330 seconds at sea level and 380 seconds in the vacuum of space. The full flow stage combustion cycle enhances efficiency and reduces wear on engine components, contributing to the reusability goals. SpaceX has continually iterated on Starship's design and construction. Recent improvements include advancements in heat shield technology, which protects the vehicle during atmospheric re-entry. Other improvements have focused on the structural integrity of the vehicle, propellant management systems. The fourth integrated flight test, IFT-4, was a critical step towards achieving a fully successful mission from launch to landing. This test showcased further improvements in the Raptor engines, structural enhancements, and heat shield performance. IFT-4 successfully demonstrated the ascent and separation phases and for the first time achieved a controlled descent and landing of the Starship spacecraft. This successful landing marked a major milestone, validating the vehicle's reusability and operational readiness for future missions. Starship's potential missions include lunar landings as part of NASA's Artemis program, where SpaceX has been contracted to develop a human landing system variant of the Starship. Additionally, SpaceX envisions using Starship for Mars missions, aiming to establish a sustainable human presence on the Red Planet. The spacecraft's versatility extends to deploying large satellites, constellations, space station resupply missions, and even potential point-to-point travel on Earth, drastically reducing travel times between distant locations. I hope this video on the evolution of reusable launch vehicles was interesting and informative. I'll meet in the next video with another interesting topic. Take care. Bye.